In this video, we're going to be looking at how we can perform a number of tests of statistical significance within SPSS custom tables. We'll begin this example by building a relatively simple table, just cross-tabulating one categorical variable against another. In this situation, we're actually going to be comparing salary to education. So I'm simply going to pick up the variable current salary. I'm going to put that into the rows, and then I'm going to put education level, which has been banded, put that into the columns across the top. Now obviously that's just going to show me the frequency count, so let me actually request some column percentages here. So I'm going to go to summary statistics, call up column percent, let's send that across, maybe just edit it a little bit, and to show that everything sums to 100% column wise, I'll just add in a row total at the bottom here. If we click OK on that and look at the results, we can see that for those with 12 or fewer years of education, that 43% of people in that group, of which there are 243 of them, earn up to $24,000. Of those in the middle education bracket here of 13 to 15 years, 36, just under 37% of those, 122 people, earn between $28,876 and $37,050. And for those with over 15 years of education, 81.7% of them earn in excess of $37,051. So we might ask ourselves at this stage, well, is this statistically significant? And certainly if you're doing a crosstab or something like that, you might ask for a chi-square test. You can do exactly the same thing here in custom tables. I can go to call that dialog box up again and go to test statistics. And I can switch on tests of independence chi-square and choose my significant level. Let's choose it to 0.01 just for illustrative purposes. Click OK at that point. It's coming out as statistically significant, and it's in fact it's the value is quite small. It's sufficiently small that it can't actually display it, but certainly less than 0.01. And we would conclude from that just looking at overall the relationship between current salary and education level, that these are not independent of one another, that that they are related in some way, and that the probability of getting a result as extreme as the one that we have observed when we do our statistical test is sufficiently small that we wouldn't see that very often, let's say, to put it mildly, assuming that in fact current salary and education level were completely unrelated. In other words, assuming that the null hypothesis is true. So we would regard this as a statistically significant effect. Then the next question somebody might ask is, we have a lot of groups here. We have 3 education groups and we have 4 salary bands here. So we've got 12 different groupings. Which ones are statistically different from one another? In other words, if we were to compare each group against one another, well, it turns out that there is a way to get that result out. It's called a Z test or column proportion test. You can see here, you can switch it on. It says compare column proportions, and it immediately switches on something called bond for only adjustment, which we recommend you stick with. Don't switch that off. That just basically adjusts for the fact that you're doing multiple tests and adjusts the probabilities to take effect of the fact that you're doing multiple tests. By default, what it will do is it will give us some results that are displayed in a separate table, and it doesn't initially give us statistical values in the sense of a probability value. It takes a little bit of use to getting to interpreting it, but we click OK at this point. What we get is exactly the same output that we had previously here with our table of column percentages, our chi-square test, and then this additional table beneath it. And the additional table here is basically telling us for that group which other groups in the table, which other columns in the table is it statistically different from. So if we're looking at column A, B and C, that's 12 years or fewer, 12 or fewer years of education, 13 to 15 years of education, over 15 years of education. It's basically saying that for people in this current salary band, they are statistically different. They're statistically higher, in this case, proportion of them on less than up to $24,000 than in this column, this group 13 to 15, and over 15. We know that because it's told us which groups it's statistically different from. It says I'm different from group B, and I'm different from group C when we're comparing it against this salary band. Group B, it says I'm also different from group C, and we know that it's already different from group A because group A has told us here. Similarly, down here, it's saying, well, okay, for these guys here, group A, 24,000 and 28,000. Let's just look at those proportions there. We're saying that's 30% to 32%. Not a big difference between A and B here, but quite a big difference between A and B. A or B compared to C, which is only 2.8%. So it's basically saying, yeah, I'm different from group C, and I'm statistically different from group C as well, but they're not different from one another. And then we have this group here, which is with 36.9%, the largest value, if you like, in that group there. It's saying, yeah, I'm statistically different from group A and statistically different from group C, where the values are 24% and 13%. And then down here, we have 13 to 15 years with the $37,051 and over group, in excess of that group. We can see 81% compared to 19% compared to 2.1%. Some quite big differences here. It's saying yes. It's saying group C here, which is the largest proportion, largest value in it. It says I'm statistically different from group A, and I'm statistically different from group B. Group B is statistically different from group C. It's not saying that this group here is statistically different from group B though. Okay, so it's showing us where the statistical differences actually occur. You can, if you so wish, add in the significance values themselves, so it will give you the probability values themselves. See, this one is here 0.02, this one 0.036, some of them are very small, they're 0.000. So it's showing us exactly how significant or how small or how large the probability value is associated with each interaction within the table. Okay, that's for proportions. What about if we're comparing averages or means? Well, it turns out we can do a similar set of tests, but this time comparing mean values. So to illustrate that, we're just going to return to custom tables, but this time we're going to be looking at a continuous variable and a categorical variable, because we're going to be comparing group means, group averages. The structure is actually quite important to get this right. It won't produce the results unless you get the correct structure. So best thing to do is put the scale of the mean variable, or the variable you're taking the mean on, into the rows. So I'm going to choose beginning salary. I'm going to compare beginning salary by age group, which I'm going to put into the columns. So I get 4 different mean values, and of course what we're interested in is whether or not any of these means are statistically different from one another. So we click on Test Statistics, and we check the box marked Compare Column Means. Click OK at that point, and we get our column means reported here. $13,752 is the average starting salary for people aged up to 26. And for those in the 27 to 29 age bracket, then the mean salary, beginning salary, was $18,000. For those aged 30 to 44, they have the highest average mean starting salary, $21,000, and for people aged 45 and over, they have a mean salary of $14,905. Which ones are statistically different from one another? That is shown here in the comparisons of column means. Choosing the largest mean value as a kind of reference group, if you like. It says, okay, this number here is statistically higher than this number, and this number, because it's saying it's statistically different from group A, group B, and group D. Whereas this number here, 18,327, it's saying I'm statistically higher than group D, and also statistically higher than group A. So it's showing us where the interactions are, where the actual significant differences are within the individual means themselves.